In this video, we will talk about lambdas. We'll cover the first subtopic of the exam topic number 3, which is lambdas. So now we will cover make and use lambda expressions. What are lambdas? A lambda is an anonymous function. What is an anonymous function? A function without a name. Maybe you know the anonymous inner classes. Now we have anonymous functions. The reason why lambdas were introduced into Java was because they wanted to have a way in which they can replace anonymous inner classes with anonymous functions. Why they want to do that? Because they want to write less code. A class is much more code than a function, so now you have anonymous functions instead of anonymous inner classes. Let's look at an example. The classic example for anonymous inner classes is swing. Like this, you would have a button and a label, and you would write like this: add action listener to the button, and within that parenthesis of that method, you would define your anonymous inner class, like on the fly. Here, this is the code in which you define your anonymous inner class, and here you implement the action performed method, which has an action event parameter, and here inside you set the text of the J label, and this you know that this method is invoked whenever the button is clicked. So whenever you click the button, then the label of the button will have this text. Now this code becomes this. This is a lambda expression. This funny little thing here, which you probably never seen before. E arrow com set text. Now, of course, this is also unusual if you never saw it before, but you have to admit that this is way more little code than this. Here you have like 4 lines, and these 4 lines become 1 line. That whole thing here became this line. So new action listener, blah, action perform, blah, blah, action event, blah, becomes this. You just have an E, and you just say comp set text, which is a method. This is an anonymous function, a function without a name. Okay, so let's look at our example. This is our example from the swing example. Let's look at the syntax. What does this stuff mean? The E is a parameter name. As in a swing example, action element E. So this is our E, and the arrow here is a separator. It separates the parameter from the body. So this is the parameter, and this thing here is the method body. And our anonymous function, our anonymous method, doesn't have a name. Parameter body. Okay. So our method, anonymous method, has a parameter, and this is the method body that is invoked whenever user clicks a button. There are some things to remember. You can omit the type of E, because compiler infers a type from E from its context. Here it looks at the signature of action listener, and it sees that it expects an action event. So you don't have to explicitly type the type of E here when it's obvious, but when the compiler cannot infer types, then you must explicitly specify the type. But you would see if you have to explicitly write out the type or not, because if there are some compile errors, then you can build your program so it's obvious. Here's an example for explicit type declaration. It's our example from before without a type. and here we can write actually the type of E, but this is optional for this example because the compiler can infer the type here in this example. Some more syntax rules to remember. An anonymous method, aka lambda expression, consists of the following: a comma-separated list of parameters enclosed in parentheses. Type is omissible, as seen above. The parentheses are also omissible if there is only one parameter. Let's look at some examples. These examples, these three lines are all valid and they are synonymous. That means they all mean the same thing. As parameter, and this is the method body, get age from S, and greater equals 18. So we we type some parentheses, but since this is a single parameter, one parameter, these parameters are omissible and we omitted them here, but we can optionally write them here. And here we write the type, and in our little example here we assume that the compiler can infer the type, so that's why we don't write it here, but we could write it explicitly if we wanted to. Number two, the arrow token, which is pretty non-brainer. This is the separator, which separates the parameter from the body. Now let's look at the body. Now the body of the anonymous method can consist of two things: A single expression, or B, a statement block. And if it is a statement, then it must be inside a block, that means inside brackets. If it is an expression, then the Java runtime evaluates the expression and returns its value. That's why we don't have to explicitly write a return statement, but we could write it nevertheless. But that would be optional and redundant. So we can just omit the return statement if it is a single expression. But if we decide to do so, then we write return, and we have to, then it is a statement, and then we have to write braces. These are important because, as we see here, the return statement is not an expression, it's hence return statement, but and statements must always be enclosed in braces. So if we decide to write return, then we must include the braces. This is important. However, there is an exception. If you have a void method, that means a method that doesn't return anything, then you don't have to enclose the method in braces. So you could just write E and then the arrow, system out print line E, which is a valid lambda expression, an anonymous function, anonymous method. And since print line doesn't return anything, we don't have to enclose the method in braces. So that was it. We have just covered the first subtopic of the lambda topic, make and use lambda expressions, and in the next video we will cover subtopic number 2, which is use lambda expressions and method references. So see you there.